Hey guys, I hope you all are doing good. So by now, I hope you have a good understanding about logical arguments and how they work, right? So in this lecture, we will be understanding about what is a proof and what are theorems, lemmas and corollaries, and we will also try to understand what are the different types of proofs that we have, right? We will cover each and every proof in a good detail. So this is going to be kind of maybe 4 and 5 lectures. So follow along, make sure that you understand everything, and if you have any doubts, then you can leave in the comments, right? Okay. Starting, let's try to understand what is a proof, right? A proof is a logical argument that demonstrates why a mathematical statement must be true, right? So let's try to understand it, right? If you're a science or a math student, then you probably understand that throughout the history, people have proven things. They looked at equations, they looked at math, they proved those things, and then those proofs were used to prove new equations, right? So far, how science works is there is somebody who solved some problem, and then that solution of that problem was used to solve another problem, right? That's how math works, that's how science works, and that's how we have come so far throughout the history, right? So that is basically what it is, right? A proof is a logical statement that demonstrates why a mathematical statement must be true. So it is very important to understand how proof works, right? So it is basically a logical argument. So what the basic idea is, when I'm trying to prove something, I need to make sure that it is logical. I follow the flow and I make sure that I explain everything throughout my proof, right? So I hope you understand the basic definition of what is a proof. Now, there are a few things to note in a proof, right? First thing is there should be no gaps in the logic. Whenever we are writing a proof, we need to make sure that we explain each and everything in detail, right? Because if I'm trying to prove something, then that is very important that I don't miss anything and I don't make any mistakes, right? So there should be no gaps in the logic. It is not that I can miss some statement or make some explanation and that would still be fine. I need to make sure each and every explanation is there. It should use the accepted truths, right? Now, another point is that whatever accepted truths have been there, right? Whatever other mathematicians agree or other physicists agree, I need to make sure that I use those truths to prove my proof, right? I cannot just form another proof or another truth value that I consider to be true and then use that in my proof, right? I need to make sure that I'm using some statements that have already been proven and are accepted throughout the community, right? So last one is should leave no doubts for the reader. This is very important. I need to make sure that whatever proof I form, right? Maybe I'm trying to write a new equation about space, right? I need to make sure that when I'm asked questions based on it, I'm able to answer all those questions, right? It should be that there is no doubt in the mind of the reader, right? There are no questions, and if there are any, I'm able to answer those questions clearly and with a valid argument, right? So I hope you're able to understand what is a logical argument. Now let's try to understand what are theorems, lemmas, and corollaries, right? Very simple terms. A theorem, what is the purpose of it? It is basically a major result, often requires a long proof, right? So a simple example is Pythagorean theorem. So I'll give you a basic idea what is a theorem, right? A theorem is simply like a long proof, right? Somebody spent a major amount of time on proving that thing, and that is what the theorem forms, right? So for example, Pythagorean theorem is an example. Second one, a lemma is a helper statement used to prove a theorem. Now, we cannot just prove theorems, right? We need some valid statements that we use to prove those things, right? And that is where lemmas play a role, right? Basically, I'm using the already existing truth values that have been considered or that have been accepted, and using those, I'm using my proof, right? Theorem. So any new theorems that come up, then it's quite possible that it is using previous lemmas that have been accepted. Okay, last one. What is a corollary? It is basically a direct consequence of a theorem. So what is the consequence of a theorem? Right? I know Pythagorean theorem is true, right? It is accepted. That means, what is the Pythagorean theorem, right? It basically says if a triangle is right angled, then a square plus b square is equal to c square, right? Where c is the hypotenuse. What is the consequence of a theorem, right? If a square, if you think about it, then that it must also be true that if a square plus b square equal to c square, then the triangle is a right angle triangle, right? It is basically this statement over here would be a consequence of the Pythagorean theorem, right? And hence I can say that this is a corollary, right? So I hope you were able to understand what is a proof and the theorem, lemmas, and corollaries. And now let's try to understand what are the different types of proofs and how do we follow along in a proof statement. So I've written down all the different types of proofs that we will be covering. I'll cover each and every one in quite a good detail in the next few lectures, right? But for now, let's try to understand just a basic understanding of all these logics, right? Or I should say all these proofs. First one is the direct proof, right? Direct proof basically means that we are directly following premises and then reaching a conclusion, right? So I directly go from any assumptions that I've made and then try to reach the conclusion from it. It might sound very weird, like isn't that how exactly we solve all the proofs? But that is not the case. There are many different ways we can prove things, right? So this is the very basic one. You can say that this is the default character that you get in your game. Next one is proof by contrapositive. Now let's try to understand what this means, right? Look, when let's say I'm trying to prove if P then Q. Maybe I'm trying to prove this, right? But instead of proving this, maybe we know that this is going to be equivalent. You need to understand that this is equivalent to negation of Q, then negation of P. If you look at the truth tables, then you will find out that P then Q is equivalent to negation of Q, then negation of P. So the basic point is that in order to prove this P then Q, maybe I can prove this is true. If I prove this is true, which is negation of Q, then negation of P is true, then that implies that P then Q should also be true, right? So that is the proof by contrapositive. If you don't understand it, then don't worry about it. We will cover proof by contrapositive in a good detail, right? Next one is proof by contradiction. Now, if you understand the word contradiction, right, that basically means contradicting something. In this proof, what we do is we make an invalid assumption, we make the opposite assumption of what we are trying to prove, and using that assumption, we make a contradiction, right? So basically, it's just try to understand that assume the opposite, follow some logic, and then prove that there's a contradiction in that case. Next one is proof by cases. This is a very simple one. Proof by cases basically means that I divide my proof into subparts, right? So for example, let's say I'm trying to prove x square is always greater than or equal to 0, right? In that case, I can have three cases. I can prove for all the values which are greater than 0 and all the values which are less than 0, right? And also third one could be when the value itself is equal to 0. So in order to prove x square is always greater than 0, I can consider less than equal to 0 values, greater than equal to 0 values, and value which is equal to 1, right? Which would make three cases in that form. Okay, next one is proof by a counterexample. This is again very simple to understand. The basic idea is in order to prove something, I give a counterexample to it, right? I'll cover this in detail, but you need to understand that let's say there's some statement. I give a counterexample to it, proving that it is wrong, right? Last one is proof by induction. This is the most important one, and this is where we will spend a major amount of our time. For now, I'll not give a basic definition about it, but I'll cover this one in detail. So don't worry about this one for now. Let's cover all these proofs in detail first, and then I'll explain how the proof of induction works, right? So that was it for this lecture. Now, from the next video, we will be starting with all these proofs, cover each one in detail, right? So I'll see you guys in the next lecture.